let's see what we have here. Number 3 says the sum of two non-negative numbers is 24. So that's the first thing you want to address, is reading this. The sum of two non-negative numbers is 24. So I'm going to pick my usual two variables, x and y. So I'm saying, okay, x plus y, because that's what sum means, right, equals 24. And again, you always want to ask yourself why they tell you that, because they're trying to ask you to solve for one of the variables. So kind of a natural thing, I'm just going to solve for y. So y equals 24 minus x. Okay, I'm going to use this in a minute. Kind of keep that on the back of my mind. All right, so let's see. Let's move on to the questions. The sum of their squares is as large as possible. Okay, we're looking for as large as possible and as small as possible. So notice now in numbers 1 and 2, I never took the time to check and see if they're truly maximum or they're truly minimums, because in these optimization problems, whenever we're dealing with the box or the dimensions, stuff like that, it actually automatically is the max or the min that you want. You actually don't need to take the time to double check. But when the problem is asking you for as large as possible and as small as possible, then there's that possibility of having a maximum or a minimum, and you gotta check. So I'll definitely show you how that works. Okay. All right. So the sum of their squares. So let's see if we can figure that out. So we're gonna square both numbers. So we gotta go, okay, x squared plus y squared, because that's summing them, is equal to this sum, and you want to make it as big as possible. So you want this s to be your s prime, right? The sum of them. Now again, looking at your equation here, you have too many variables. That's why I want to replace the y. So you have x squared plus y squared equals your sum that you want. And so I'm going to put in my 24 minus x here. Okay. Now, because this is small enough, I would say that I would go ahead and multiply it out, right? Oh, so the question is, why do you solve for y first and not x? You can. Then your equation in this next step will be in terms of y. It's up to you. So yes, you are right. The question is, why do you solve for y? You can solve for x or y. You're solving for one of the variables. So it doesn't matter which one. Whichever one is easier for you to work. All right. I like solving for y because I'm used to that. So that's just a personal preference. All right. I am going to go ahead and multiply this out. I get x squared plus 24 squared is 576. Yes, I'm right. And then don't forget you have a minus 48x as a middle term. And you still have your plus x squared. So your sum function, s of x, is equal to 2x squared minus 48x plus 576. And this is where you need to take s prime, because you're trying to find as big or as small as possible. You're trying to find the max or min of this sum. So s prime equals 4x minus 48. You set it equal to 0. And you solve. And you get 12. So, do we know if this is a max or minimum? We don't. But in this particular case, you have endpoints, because it's saying that the sum of non-negative numbers, I can't have any negative numbers. So the smallest number my number can be is 0. The biggest number that it can be is 24, because 0 plus 24. Those are your two endpoints, right? So again, you have to read the problem and see what is logical to you. So the smallest number that x can be, not the sum, the smallest number is 0. And it's not sharing. Give me a second. It's not popping up again. I swear. Anyway, this is a lot better than the problem we had before, so I am grateful. I don't want to be angry and jinx it. This is not showing up with what I'm writing. Okay, the smallest number is 0. The largest number is 24. Okay, again, why? Because I'm adding up to 24. That's the logical sense and they have to be non-negative. If you can be negative, then you have endless possibilities, or a little bit more endless than what you have here. But because they're non-negative, so the smallest is 0, the biggest is 24. And now you have this x equals 12. You have this thing that I don't know if it's max or min. So now the easiest way to go about it is to plug the endpoints and this extrema in, and then compare the sums to see which one's the biggest and which one's smallest. So I am going to go ahead and plug in s of 0, s of 12, s of 24. And I'm going to plug it into right here. This is my equation for the sum. Plug it in there and see what I get. S of 0 is nice because I get 576. I just plug it into the x there, and I get 576. Okay. Again, I don't expect you to do this part by hand. It's just very, very time consuming. So I plug in the 12, and 12 is 144 times, 12 squared is 144. 12 squared is 144. 144 times 2, I get 288. Oopsie. All right, 288 minus 48 times 12, that's minus 576, plus 576, so that gives me 288. Okay, that's gone. Very nice. Okay, and then I have s of 24, so 24 squared times 2, that's 1152, minus 48 times 24, that's another 1152, plus 576. Awesome, so 576. Okay, so based on what I see here, I have my maximum at either 0 or 24, and I have my minimum at 12, right? So how do I answer the question? So I will say largest sum when the numbers are 0 and 24. It doesn't matter which one's 0, which one's 24. If one of them is 0, the other one's 24. If one of them is 24, the other one's 0. So 0 and 24, they'll give you the largest sum of 576. Smallest sum when the numbers are both 12. Because if one of them's 12, the other one has to be 12. They have to add up to 24. So the other one is, they're both 12, then you have the smallest sum. So that is the answer to part A. So when you're just taking the two numbers and you're squaring them and getting the sum, it sometimes wouldn't matter which one's which, or which one's A and which one's X and which one's Y. But the next one, it does matter. So the next one says, you take one number plus the square root of the other, and you want to look for the largest sum and the smallest sum. Same as always, right? Same as before. So you're going to take the number plus the square root of the second one to get you the sum. And Miss Shu, why can't you do Y plus square root of X? You can't. It doesn't matter. It's just the way you answer your question is going to be a little bit different, but it doesn't matter if you set it up as Y plus root X versus X plus root Y. I just kind of went in order. So the first number I saw, I put it as X, and then the second number says square root of the second number of the other number, so I just put that as root Y. All right. So again, that part you can decide who to go first. So X plus, I still have the same condition as before. So Y is still 24 minus X. Equal to the sum. And now you want to take S prime as always, because you're trying to find the maximum and minimum. You want to try to find the largest or the smallest. So S prime equals, the root of the first one is 1. That one's nice. Plus, you have the square root of 24 minus X. And I've talked about this a little bit earlier. You really need to see the square root of 24 minus X as 24 minus X to the 1/2. That way it's a lot easier to take the derivative, right? You drop down the 1/2, get 24 minus X to negative 1/2. Then you have the chain rule, the derivative of the inside is a negative 1. And then that's it. All right, I don't want to take up that space, but that was just kind of like my workspace to work out that issue. So you have 1 minus 1 over 2 root 24 minus X. You always want to rewrite it so it looks like a fraction. And in this case, I got nothing in common in my denominator, so I can put a 1 under and do my crisscross applesauce. So I get 2 root 24 minus X minus 1 all over 2 root 24 minus X. And again, and the beauty of optimization is that I don't need to care about my denominator anymore. So I simply simplify this and make it 0 equals 2 root 24 minus X minus 1. Add the 1 over. 1 equals 2 root 24 minus X divided by 2. 1/2 equals root 24 minus X. Square both sides because you want to get rid of that root. So you get 1/4 equals 24 minus X. So if you want to add X over, is 1/4 plus X equals 24. So X must equal 24 minus 1/4, which is 95 over 4. All right, so now I have this x equals 95 over 4. Again, I don't know if this is the maximum or minimum. I still have the same boundary as before. The smallest my number can be is 0. The biggest my number can be is 24. But when I plug it in, I'm plugging it into this x right here. So again, if you were doing it as y is the first here, then you're still going to plug in your y equals 0 and 24 into your equation. You'll get the same thing. It's just your variable is different than what we have here. Okay? All right, you got to test. So you got to check and see s of 0, what is the sum when x equals 0? What is the sum when x equals 95 over 4, so really close to 24? And what is the sum when x equals 24? And you don't want to plug it into the derivative because it's not a test. You're plugging it into your s function because you're trying to compare. Sorry to use the word test. You're trying to compare the sum at each of those levels to see which one gives you a true max, which one gives you a true minimum. All right. So I plug in 0, I get 0. Oops, I get 0 plus root 24 minus x, so root 24. So I just get square root of 24. Okay. All right, 95 over 4. This is kind of awesome. So 95 over 4 plus root 24 minus 95 over 4. Okay. All right, what is that? That's 95 over 4 plus, we had 25 minus 95 over 4. 24 minus 95 over 4 is 1/4. So this is 95 over 4 plus 1/2, which gives us 97 over 4. It's important to know that, 97 over 4. And if you want, you can do a calculator one just to really quickly see the answer. So this is 24.25. And then root 24 is about 4.899, just so you can compare later, okay? All right, lastly, plug in my other endpoint, plug in 24. I get 24 minus root 0. I get 24. Okay, so now it should be pretty obvious that I have my minimum here. This is the smallest number. This, shockingly, is the biggest number because it's bigger than 24. So I'm going to answer my question, say largest sum when first number is 95 over 4 and second number is 1/4. If you subtract from 24, you get the other number as 1/4. They're still non-negative. They still add up to 24. That's the condition. The smallest sum when the first number is 0 and second number is 24. Not true the other way around. If your first number is 24 and the second number is 0, that's not the smallest sum. So again, this is the only one where not only one, but this is the type of situation where the order does matter. Which one's your first number versus your second number? Whereas in the first one, in part A, it doesn't matter which one's your first number or your second number. You'll get the same answer. Okay. So I would say the 4 I'm giving you here in optimization are things that you see very often. And the good news is this is kind of where we're going to cut off, kind of give you a break to think about all these problems before we move on to a new idea when we come back from Thanksgiving. So that's good news. This is all we're going to do up to Thanksgiving. You have a quiz on Thursday, and then we're done. No homework weekend. Okay. All right. Last one. This one should be pretty familiar, right? You have these fencing problems, right? You saw. I'm hoping you saw a lot of fencing problems. No, not the fencing problem, but the fencing problem in trig. So you have an area, a rectangular P patch is to be enclosed by a fence divided into 2 equal parts by another fence parallel to one of the sides. So I'm going to quickly draw this. You can draw your picture looking like this. You can draw your picture looking like this. Doesn't matter. Oh, it's not working again. No wonder you're like, what is going on? Let's try again. So there's 2 ways to draw your rectangular patch being divided into 2 sections. And one way is to have it vertical and one way is to have it horizontal. So one way or second way. Doesn't matter. Again, we'll get the same answer as long as you name your dimensions the correct way, you'll get the same answer. All right. So what do? I don't know. My notes, I want to match what I had in my in the things I posted for you. So in my notes, what I did was I don't have all this stuff here because I need some space to work. So I'm going to clean this up real quick. so I can have space do work for you. Oh, it takes a long time to erase. Okay, great, perfect. So I did it this way, where I had a nice rectangular patch. And then what I did was I just cut it in the middle like so. Okay, so oh, cricket, that's fine. One general rule I have for myself is any horizontal line, I label that as X. Any vertical line, I label that as Y. And in a situation like this where my X got cut in half, I actually label each of the small pieces. So I should label this as X and X, X and X, Y, 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 right? Because this is the piece where it gets cut into your fencing, right? However, it says this whole thing is 216 square meters. So the whole thing is 216, right? So how do I deal with that? I need to figure out that, oh, that 216 is this base times this height to get that area. So that's a key point in this problem. You know that the 2x times y equals 216. Same question as before. What would you solve for? Personally, I just solve for y because I'm just so used to solving for y. You don't have to. You can solve for x. Entirely up to you. All right? So I'm divide by 2x, so I get y equals 108 over x. I do reduce it out if I can because it's going to be helpful later. Okay. All right. Now I want to know blah, 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 blah. What dimensions for the outer rectangle will require the smallest total length of the fence? I want to know the keyword, smallest length of the fence. So I need to fence everything, including that middle piece there. So the length of my fence, the length, L, is 4x plus 3y. Because I got 1, 2, 3, 4, 5, 6, 7 pieces here. So I got to have 4x's plus the 3y. Okay, I have the y solved for already. The y was 108 over x. So this gives me 4x plus 324 all over x. And this is my equation for the length of the fence. Since I want the smallest length, I need to take L prime, right? It's the smallest length of L prime. So before I do so, it might be helpful to rewrite the original L function as 4x plus 324 x to the negative 1. So it's a little bit easier to see my derivative. Okay, so to the left here, L prime equals 4 minus 324 x to the negative 2. Okay, the derivative of 4x plus 324 x to the negative 1 is 4 minus 324 x negative 2. Rewriting as a fraction, 4 minus 324 over x squared. No denominator in common, so put a 1 under. I can do my crisscross applesauce nicely. So 4x squared minus 324 all over x squared is equal to 0. Reminding myself this is optimization, so just the numerator is enough. So add the 324 over, divided by 4, you get 81. X equals 9. X does not equal plus or minus because this is the length of a fence. So you only want the positive value. So my X is 9 meters, right? This is one answer. It wants the dimension, right? So what dimension? It wants to know the outer rectangle. So it wants to know what's this whole base and this whole height. Well, I got my X, so what is my Y? I'm going to go back to using this. So Y equals 108 over 9. Y equals 12. So there's my dimension. I'm going to use that to write my dimension. But also, I need to figure out this last question. How much fence will be needed? So now that I have my X and Y, I can go back to the original one if I want to, or I can just plug in X. It's up to you. So my total fence that I need, the total length I need, is 4 times 9 plus 3 times 12. So that gives me 36 plus 36, that's 72 meters. Okay, so how do I answer this question? I will say the dimension of, okay, the base here is 2x's, so 2 times 9 is 18. 18 meters by 12 meters. We'll use the least fence material of 72 meters. This will answer both questions of dimension and how much fence you need. You need 72 meters of whatever material you want to use.
Miss Chu,
Yes.
how did we know that line, which is the answer we got from like solving for L prime, how do we know that that was a minimum and not a maximum?
That is a good question. So typically, if you really want to know, you can go ahead and take the second derivative and solve for it, and then you plug it in. But I will say you are pretty safe in assuming that once you take the derivative, this is the max or the min that you want.
So like unless we like really wanted to be careful, we can just assume that it's whatever the problem asked for.
Honestly, yes. I know that's a terrible answer from me, but honestly, yes, to save you time. And unless it's like number 3, where it does ask you for the max and the min, then you got to be more careful to figure out which one is which. But in numbers like 1, 2, and 4, if it's asking for the min or the max, it's asking for one of them. In these cases, 99.9% of the answers that you get is what you want. So saving you time. Okay?